What's up guys, it's Simon Fiaz and today's video is on AQA A-Level Chemistry 2023 Paper 3 June 2023. State the role of concentrated sulfuric acid in this reaction, and it is an ester being made by reacting an alcohol with carboxylic acid. Present concentration of sulfuric acid is a catalyst. The reaction mixture is flammable, suggests how it should be heated via electric heater or water bath. So we'll just say electric heater, because if we use a Bunsen burner flame, it's very dangerous since it's flammable. So electric heater, split those words up. Identify two mistakes the student made in setting up the apparatus. State the problem caused by each mistake. So first one is the water flow. So water goes the wrong way through the condenser. Water goes the wrong way through the condenser. Problem caused: water does not fill the condenser. Mistake 2: there is a bunge at the in the end of the condenser. Pressure build up. Water goes the wrong way through the condenser. Water does not fill the condenser. There's a bunge in the end of the condenser. Pressure build up. Explain why there's a build up of pressure in the separating funnel. No, it says state why sodium carbonate is added to neutralize the acid. Actually, to remove the acid. And why is a build up of pressure? There is a build up of pressure as carbon dioxide is produced. Give a reason why two layers form in the separating funnel and suggest why the ester forms the upper layer. Two layers because ethyl ethanoate is immiscible with water, and why it forms the upper layer. Ethyl ethanoate is less dense than water, has a lower density than water. Ethyl ethanoate is immiscible with water. Ethyl ethanoate is less dense than water / has a lower density than water. To remove the acid, there's a buildup of pressure as carbon dioxide gas is produced. State that hydrous calcium chloride is added in step 6. It's because of acts as a drying agent. Yeah, that's that one. As a drying agent. Another example of a drying agent is magnesium sulfate. In case exam question comes up, like state another example of drying agent, magnesium sulfate. Then it says question 1.7. A student using a method to prepare some ethyl ethanoate ester. Student adds this much ethanol to this much, obtains this. Determine the limiting reagent. So first thing I'm going to do is I can see that density is mass over volume. Therefore mass equals the density. Well, this is the volume times by density times volume, 10 times by 0.790. Then I get the mass is equal to 7.90 grams. Then I want to find out the moles. Yeah, I want to find out the moles of ethanol. Which is just going to be 7.90 grams, the mass over the MR. And the nice thing about this question is it gives us the MR. For some of these questions, or a lot of them actually, it doesn't give us the MR, and that's why I struggle with the most, finding out the MR of these particularly larger compounds or molecules. Then moles of 10 moles of the ethanoic acid, because I was just a bit confused. I've got ethanoic acid, ethyl ethanoate, and ethanol. So moles of ethanoic acid, which is just going to be 5.25 over 60, and then so 7.90 divided by 60, and I get 0.131. 5.25 divided by 60, 0.087. 0.087. 7.90 divided by 46, 0.171. So the limiting region is in the limiting region. Well, that's going to be the ethanoic acid, since that's got fewer moles. Because moles of ethanoic acid 0.0875, moles of ethanol 0.172. So ethanoic acid is the limiting region. Then it says calculate percentage yield of ethyl ethanoate. Well, the percentage yield of ethyl ethanoate, I know I obtain this much of ethyl ethanoate, so 5.47, the actual yield over the theoretical yield times by 100, right? And the theoretical yield, well, what I would do is I'd use the moles, right? But I'm not going to use the limiting region moles, ethanoic acid. I'm going to use the moles of ethanol, 7.90 divided by 46. Then moles' mass of MR, mass is going to be the moles times by the MR of ethyl ethanoate, and then use that. And I get oh no, never mind. We do use the moles of ethyl ethanoate since yeah, that's the limiting region. Then it says calculate the percentage yield ethyl ethanoate. Yeah, so I use the moles of ethanoic acid. It makes sense. Why else would they find the limiting region, then calculate percentage yield? So I use the moles of ethanoic acid 0.0875 times by 88, 7.7, 5.47 divided by my answer times by 100, and I get 71%. 71.0%. So first thing you do, density, mass of volume, find out mass, find out moles, which one's limiting region, the one in fewer moles. And then therefore to find out percentage yield, it's going to be this divided by using ethanoic acid moles times by the MR to get that, and you get 71.0%. So just a reason why the percentage yield is not 100%. Reaction is reversible / an equilibrium. Reaction is reversible / an equilibrium. Question 2. Draw the displayed formula for unbranched position isomer pentane 2-ol that can be dehydrated to form a single alkene. So displayed formula of pentane 2-ol that can be dehydrated to form a single alkene. So displayed formula of pentane 1-ol then. So methane, ethane, propane, butane, pentane. Draw the discrete formula of a chain isomer of pentane 2-ol that can be dehydrated to form a mixture of alkenes. So I'm going to look for something like methane, ethane, propane, butane. Methane, ethane, propane, pentane, and yeah, 3-methyl butane 2-ol or 2-methyl butane 2-ol, because just get from the pentane that can be dehydrated from a mixture of alkenes, because those two will form a mixture of alkenes. Draw the structure of unbranched functional group isomer of pentane 2-ol, unbranched functional group isomer. So just something like this. Another isomer of pentane 2-ol is alcohol that is not dehydrated when heated with concentrated sulfuric acid. Draw the structure of this isomer not dehydrated. So it's going to be Another isomer of pentane 2-ol. So methane, ethane, propane, butane, pentane. Pentane 2-ol, right? So what I can have is CH3, C, CH3, CH2OH, CH3. Name the mechanism for this reaction. Elimination. Yeah, elimination. The dehydration reaction. Elimination. And then complete mechanism. So what happens is bonds to H plus the lone pair electron, oxygen minus. Then what happens is then you go from here to here. Yeah, and then the carbon positive charge, and they go from here to here. So there to there, and then there to there. Obviously, I like to show it's two separate steps, but in this part, you need to do, yeah, just do it like that. An isomer, the final product, can also form in the reaction question 2.5. Draw the structure of this isomer. The isomer of this, well, it's just going to be C6H6, C double bond N, O, C, C, C6H5, H. Yeah, instead of that, I can have C6H5H. These joined together. I've got double bond CH2 here. Then it says, complete structure of endomorphin 2. And it has NH2 at the end of the amino acid. It shows that it's an amide, not acid. So I've got this. And what I want to do is I want to show that the terminal functional group is an amide, not an acid. This is an amide, not an acid. Okay, so I'm going to have an NH here, CH here, C double bond O, NH2, CH here, CH2, and then, you know, your phenol group attached to it, your benzene group, sorry, attached to it. And there you go. Use instruction figure 2 to draw the skeletal formula proline, PR. The skeletal formula proline, well, it's going to look something like, okay, NH here, and you've got this here, that there, OH. I shouldn't, yeah, like, analyze linear chromatography, you can't do that. Can't do that, I haven't even gone through chromatography. I thought that the first part was amines and amides. No. Question 4. Maybe I could do this. Red brown precipitate. No, I don't think of iron salts, 2 aqueous solutions, observation L, observation M. No, I don't think I can't go for this as well. I think this is a let me check in the year 2 book. Year 2 book, transition metals. Yeah, year 2 book, and I go to transition metals at the end of it. Metal acre ions, and yeah. Yeah, can go for this one as well. Don't think. So moving to the next one. Question 5. Calculate delta H of vaporization for water. And I know the molar enthalpy of vaporization is the enthalpy change. Perfect. That's the enthalpy change of a molar liquid. So basically, if the question told me calculate enthalpy change, what would you do? Well then, Q divided by moles, right? I had to find out Q, mc delta T, where m is the mass of water. And I know loss in mass is that. I can find out the moles, but what about Q? Well, Q is the heat energy transferred, right? But I know I can't use that. It says a 2.4 kilowatt heater to raise the temperature 200 degrees Celsius to boil the water. So, and I know 1 kilojoule watt equals 1 kilojoule, but obviously Q is measured in joules, so it's basically just going to be 2.4 times by 1,000. That's it. 2.4 no times by 100. Yeah, because he uses it to boil water for 100 seconds, and I want my answer to be in kilojoules, because my final answer needs to be in kilojoules multiplied minus 1. Divided by the moles, well, the moles is going to be the mass of the ml of water, 18. So 2.4 times by 100, divided by 103, divided by 18, and I get plus 42.0 kilojoules per multiplied minus 1. So I know that's the enthalpy change. Heat energy transferred, well, it's 2.4 kilowatt for 100 seconds. So the heat energy was 2.4 kilowatt per second, right? So which is going to be that times by 100. That's heat energy. And then the moles are just mass over ml, mass over the ml of water. And then, yeah, we get that plus 42.0. Ethanol is the most polar and ethyl amine is the least polar. Explain why all three molecules are polar. My ethyl amine is the least polar, and your answers refer to the shapes around and relative electronegativity of most electronegative atoms. So what's it saying? It's saying all three compounds in table 2 are polar. Ethanol is the most polar. Ethyl amine, so the second one, CH3, CH2, NH2, is the least polar. Explain why. Explain why ethyl amine is the least polar. Explain why all three molecules are polar. So first things first, oxygen and negative, more electronegative than carbon. So they all have polar bonds, because we've all got oxygen and nitrogen in them. Whereas CH3 CH2OH and CH3OCH3 both non-linear, and CH3 CH2 NH2 is trigonal pyramidal. So I marked just for saying the shapes, just for finding out the shapes and stating the shapes. Shapes are not symmetrical. So molecules are polar. They're not symmetrical, the shapes, are they? Oxygen more electronegative than nitrogen, hence why ethylamine is the least polar. Okay, so oxygen and nitrogen more electronegative than carbon, so they all have polar bonds. CH3CH2OH, ethanol, and CH3COCH3, both are non-linear. CH3CH2NH2 is trigonopyramidal. So I'm using my knowledge of bonding, right? Naming the shapes. What this tells me is that none of these shapes, all of these shapes are unsymmetrical. They're not symmetrical, so therefore the molecules are polar. Because remember, if they were symmetrical, the dipoles would cancel out. So they're not symmetrical, so molecules are polar. And then why ethylamine is the least polar is because oxygen is more electronegative than nitrogen, and this ethylamine doesn't have an oxygen in it. So therefore, or you could say nitrogen is less electronegative than oxygen, hence why ethylamine is the least polar. Then it says explain trend in boiling points of the three compounds. So boiling points, hydrogen bonding, that's what I'm going to talk about. And I can clearly see ethanol definitely has hydrogen bonding. Does ethylamine nitrogen bonding to NOF atom bonding to? Yes, it does. Why is this does not? So I'd say hydrogen bonding in ethanol and ethylamine, and permanent dipole forces in CH3CO CH3. Yeah, this doesn't have hydrogen bonding, because the hydrogen bonding to happen, an NOF atom has to be bonded to a hydrogen. But if you draw out this, it's literally like this: CH3 C double bond O CH3. So the oxygen is bonded to a carbon as a ketone, so then it's not going to have hydrogen bonding. But it also does have permanent dipole force, because I know from part A of 5.2 that shapes are not symmetrical, so molecules are polar. So that's going to have permanent dipole forces. And obviously, the final thing is hydrogen bonding stronger than other intermolecular forces. Hydrogen bonding stronger in ethanol than ethylamine. And if you look at it, yeah, because oxygen more electronegative, stronger hydrogen bonding. Question 6. Show by calculation that calcium hydroxide is in excess. It says calcium hydroxide is almost insoluble in water, but it reacts with dilute hydrochloric acid. Shouldn't add this much hydrochloric acid to this much calcium hydroxide, show that calcium hydroxide is in excess. So first thing I would do is find out the moles of HCl, which is concentration and volume. So 0.100 times by 100 divided by 1000, and that is 0.01 moles. Then I find out the moles of calcium hydroxide. A mass of Mr, 0.600 over the Mr of calcium hydroxide. Periodic table. For some reason I can't find. Oh, there it is. So calcium hydroxide, calcium is the one I need 40.1. So it's going to be 0.600 divided by 40.1 plus 16 plus 2. I'll just write that down as well. No, 40.1 plus 16 plus 16 plus 2. Remember the 2 outside the bracket. And then you get the moles as 8.0, I guess 8.010 times by 10 to the power minus 3. And there we go. I've shown by calculation that calcium hydroxide is in excess. And then we'll say something like 8.10 times by 10 to the power minus 3 moles of calcium hydroxide required. 8.10 times by 10 to the power minus 3 moles of calcium hydroxide requires 0.0162 moles of HCl. Or we could say 0.01 moles of HCl requires 0.005 moles of calcium hydroxide, which makes sense because if I got 0.01 of this is a 1 to 2 molar ratio, so that's going to be 0.005 requires 0.005 moles of calcium hydroxide. And then 6.2 says the final mixture contains a saturated solution of calcium hydroxide at 293 Kelvin. At 293 Kelvin, the solubility is that, Kw is that calculated pH. So I'm using Kw. I want to calculate pH. Now obviously it's not going to be as simple as Kw. So let's write down the Kw expression. Concentration of H plus times by concentration of OH minus. I want a pH, so I need to find out the concentration of H plus, which is Kw divided by concentration of OH minus. And I know Kw, given in the question, 6.80 times by 10 to the power minus 15. So that's pretty nice. But then the rest of it, now we need to find out the concentration OH minus. I know the solubility in this solution is 0.40 grams per dm cubed and gram per dm cubed, and I've got so I know the solubility of calcium hydroxide is 0.40 grams per dm cubed. And obviously I need a concentration of the hydroxide ion, so what I need to find out is the concentration of calcium hydroxide, and then remember to times by 2 since there's 2 hydroxides here. But how would I find out the concentration of hydroxide? Moles concentration of volume. Concentration is the moles divided by the volume. And I already have the moles of calcium hydroxide, right? Actually, no. I'm not going to use that because this says the final mixture contains this much saturated solution. So, and I know 0.40 grams per dm minus cubed. Alright, so grams per dm minus cubed to moles per dm minus cubed. So that's it, that's what I need to go. Grams per dm minus cubed to moles dm minus q. Basically, all I have to do is divide by the mr. So I'm going to do 0.400 divided by the mr of calcium hydroxide, which is 40.1 plus 16 plus 16 plus 2, 74.1. Now this gives me in moles per dm minus cubed. And that's obviously the concentration. Solubility of this is that. Yeah, that's the concentration. Then what I know is, because I've obviously got 2 hydroxide ions, then I need to times it by 2. So I do 0.400 divided by 74.1 to convert into moles per dm minus cube, grams per dm minus cube to moles per dm minus cube, just divided by the mr. Then times by 2, and I get 8 over 741. I'm going to leave it like that. Then I use pH equals minus log 10 concentration H plus. So you get that times by 10 to the power minus 15 divided by 8 divided by 741 concentration H plus, then pH is minus log 10 of my answer. 12.20. Perfect. So use KW expression, write that down first. Rearrange. What do I need to find? I've got KW, I need to find concentration of hydroxide ions. Now I'm given the concentration in grams per dm minus cube. I don't want it in grams per dm minus cube. I want it in moles per dm minus cube. So KW is also in moles to dm minus 6, moles per dm minus cube, basically. So grams per dm minus cube to moles per dm minus cube, I divide by my mr. So it's going to be 0.40 divided by 74.1. But then I also know it's calcium hydroxide. It's got 2 hydroxide ions. Then I times it by 2. Then I substitute that in. Then use pH minus log 10, the concentration H plus, to get my final pH. And that is the end of section A.